Okay, so now I am starting the session. Rest will join in a meanwhile. Basically, first of all, I will start with my introduction. My name is Sumit Kumar. I am PMR Research Scholar at IIT Ahmedabad. In this introduction, I am taking the Geotechnical Engineering 2. This is the coursework which is at NPTEL taken by Professor Dean Singh sir from IIT Bombay. I will interact with you in this session. I will cover the concepts regarding whatever taught at the NPTEL courseworks. In these interactions, whatever material I am presenting to you, that will be also be shared with you. Apart from that, if someone who are not here want to see these interactions later, so this interaction is also recorded by me and get uploaded at YouTube, and that link will be shared with you from the NPTEL team side. And if any confusion regarding those, you can contact me. You can text me here in the text box, or you may also comment at the YouTube links if you have any problem. You can pin the message in a text box. I will react to that. Okay, so in this one more point I want to mention that the meeting will go for the 2 hours, and if at certain point of time due to any reason the net connectivity got down or call get disconnected, please be remain in the meeting. I will again join in a meanwhile, so you will get the full interaction sessions. There is nothing like that if the call is disconnected from my side due to any network issue, so you have to leave. You have to remain in the meeting. This meeting will conclude at 5, and when I say that the meeting get concluded, afterwards the meeting get concluded. Due to any other reason, if call get disconnected, we remain in the meeting. I will join within 1 minute. Okay, some more points I want to discuss that in these interactions. I am covering in such a way that if someone start watching from this session only, also he will get the throughout the concept. So I will take a quick recap what we have learned in the previous two sessions. A very quick recap in 10 to 15 minutes, and that will help those learners who are start watching. They not don't feel blank while going through those concepts or questions what I am taken during the last two sessions. Apart from that, those sessions are there on the YouTube as well. But if someone new person joined over here, so he doesn't feel that I am not getting, I will do that up to the certain topic is going on. After the topic gets changed, I will stick with that. Basically, the whatever the background required for you during the discussion will be understood if you join the meeting. So now I am going to start the presentations, and first of all I will give the quick recap in the first 10 minutes of the last two sessions. Afterward, we will start with the new content. In the meanwhile, I also hope that some more person will join so they get benefited. And okay, so first of all, I am starting with the first session revision. Then we will go for second session, and this is a very quick recap. So if any doubts were there, you can text me in the text box. I will take those doubts at the end of the session. Okay. Now I am sharing the first presentation for the revision purpose. In the first 10 minutes, we will take those two sessions revision very quickly. So anyone if start watching from here doesn't feel that what is going on. Okay, so first of all, we have started our discussions from here only, in which we have taken the study of what is the shear strength soil, what is the basic concepts we have understood. So those things are there over there. So first of all, we start from there and then going ahead with the broader aspects of concepts, so that will enhance your uh, knowledge base in this topic. So give me a minute. I'm doing some aspects to share the screen in a proper manner for me as well. Okay. Now it is okay for me. Now I am starting the session. First of all, we will going to define this. So first of all, we have studied that what is the shear strength of soil, how the shear strength is so much important in the geotechnical engineering, as we have know that we are studying the geotechnical engineering too, in which we implement the basic soil mechanics study each point to the broader aspect, so we could get the we can use those aspects in practical implementation. Basically, most of the things basics we have studied during our geotechnical engineering one course, or maybe at some institute the soil mechanics one or geotechnical engineering one. So this is the second part of that subjects only, where we are dealing with the application of those concepts in a practical life. Okay. So first of all, in a shear, whenever we talk about the shear strength, we start with what is the value of cohesion, what is the value of angle of internal frictions. The cohesion is related to cohesive soil, while angle of internal friction is related to cohesionless soil like sandy soil, gravelly soil, and those have their own aspects. We are going very quick. We are not taking anything in detail. If any questions are there, you can pin in a message, in a text box. Okay. And afterwards, we have read the triaxial test and direct shear test. The direct shear test and triaxial test are taken in so much detail in the last lecture. And in a coming week, also, we are going to discuss the triaxial test, and we also solve some of the problems. And that will help you the practical implementation of those triaxial test. And there are the very good problems get solved on this topic if you are at any professionals, then this test results will help you to find the shear strength parameters as well. And if you are preparing for certain exams, so there is the favorite question from this topic in any competitive exam if you are preparing. Okay. So moving ahead, we have studied the importance of shear strength. Basically, shear strength is so much important thing that it is used in at every places in the geotechnical engineering. In any geotechnical structure, first of all, we understood that what is the shear strength and how it will vary. What is its strength? At what value the soil gets filled in a shear criteria? Because we know that whenever we talk about the geotechnical engineering soil mechanics, we first of all our focus at the value of shear strength, how much strength it will take, not about the compressive strength or kinetic strength. That is what we discussed during our RCC class or steel class or strength of material class. Okay. So shear strength, when we talk about the shear strength property in the granular soil, when we talk about shear strength property in the clay soil, those is in a granular soil, it is due to the particle to particle interaction, while in a cohesive soil it is due to cohesion. And the cohesion property of soil gives the shear strength, and it is the most important factor over there as well. Moving ahead, when we talk about the loadings and shear failures, we will relate the value of sigma x, sigma z to get the value of sigma and tau, the normal stress and shear stress at any other inclination from the given alignment. So that we will reading, we will also try to convert that when the load is actually acting in the three dimension, then how the two dimensional study will state. Basically, we are taking the plane strain criteria in a way so that will serve the purpose in the geotechnical engineering. So we can solve the complex geometry with more ease in a practical implementation. So the triaxial element, we are taking those, we are taking the revision recap of those concepts in a week two revision session. So that will coming ahead. Okay. So, and the state of stresses in soil, that is the shear stress and normal stress, what I am talking about, we also have studied. This is the most important concept. I am mentioning this point again and again because this is the basic understanding that soil get fail at the critical combination where the shear strength is just above the shear stress is just above the what is the value of shear strength acting over there. So that is represented as tau equal is greater than tau critical, and it is implemented by these two pictures. You can see that. So I am not explaining this up to that extent because I have discussed last two times in very elaborate way. So you can go through there as well. Okay, so the triaxial state of stress. Basically, when we cut any sections, when we take any consideration of a soil below the ground, the stress are acting from the all the three direction, not the two direction. But when we study, when we calculate the value of sigma and tau, we use the relations for sigma x and sigma z, but we neglect the third dimension like sigma y z, and sigma yx. So that is because we consider the plane strain case over there. We have neglect the stresses in the third dimension. Now the conversion relation of tau and sigma is given here. We have solved so many problems on these topics, and I also give you homework that please solve more problems by taking different consideration. I hope you have gone through those, and that will help you up to a certain extent as well. Okay, so the basic concepts I get this to you, so you will get revived. This is the most basic concept. In a subsequent slide, I will explain one of the figures, so you will be more familiar with this concept about the Mohr circle. That how Mohr circle act. What is the center of Mohr circle? What is the radius of Mohr circle? What is the value of principal stresses? What is the value of major and minor principal stresses? What is the value of normal stress on the shear plane, and what is the value of stresses value, basically sigma and tau at certain inclination in the Mohr circle. There is a very good problem which also solved during this course, and those presentation will be shared with you. I am just giving a revision to you for your convenience, so it will help you. Okay, and this is the sign convention. This is explained in a very fine manner. So you need to be remember these concepts. And when we are talking about the major and minor crystal states, if we are talking written sigma x over there, you consider it as sigma one. If it is a major or minor principal stresses, and similarly if sigma z is there, then it is a sigma 3. I think there is no point of problems in this discussion. Okay, so we are going ahead in our discussion. So we have developed the general solution and the Mohr circle analysis. I will explain this Mohr circle analysis with this example. We have studied that what is the value of the center of the Mohr circle. So this is nothing but sigma 1 plus sigma 3 by 2 and 0, and how it is happening is explained in the first lecture itself in a very wide manner, but you need to understand as well as remember these point as well, because these are the most basic problems. If you go in any either if you talk about the weak exams like engineering services or get this question specifically in engineering services, there are so many times the questions are asked which are related to the strength of material as well as geotechnical engineering, and those get solved within less than 1 minute if you have the understanding of this graph. So how the question get asked and how you will answer will only depend what is the concept with you. So please be confident with this graph and solve some more problems on this as well. Okay. So moving ahead, this is the relation to get the major and minor principal stress. I'm not going to discuss in detail of this because this is only revision. Some of the problems are also there. This presentation is already shared with you. So please solve those problems. And also consider some more problems. At the last, some homework is always given to you. So perform those homework. That is not the compulsion from my side, but if you do that, that will be get you will get benefited in one way or the other. Now we are talking about the application in civil engineering. Whenever we talking about when we are reading any concepts, so we first of all think, is it significant for us? So we are thinking that what is the significance of studying this? Afterward, we came to see that okay, it is significant, but where we apply this concept? So those applications are also equally important. Basically, if anything we are studying, that must have some significance as well as application. Otherwise, no point to study anything. Basically, knowledge never go in vain, but we are trying to achieve something. If we are reading any novel, we get to gather some of the good points from there as well. That will enhance our life, enhance our personality. So nothing is go in vain, but we always think that what is the significance? Whatever we are doing whether will be useful for me in some way or the other. So the application is very important. Okay. Now, the active and passive state of material will be discussed later in a very detail. So, this is the things. And the pole is also most important things which is discussed in the first course. That is, I am going with only definition that pole is a point on the Mohr circle through which all the plane will pass. So I think time is going ahead, so I will go a little faster to complete the revision. Afterward, we will start some new session. Okay, the general state of stresses is also very simple thing. So where we have solved some of the problems, and this is the one of the very good problems where we is solved by the analytical method as well as the Mohr circle method. So must go through this. Whoever joined for the first time during this session and haven't gone through my presentations or videos, so please solve this problem. This is a very important problem for your understanding of the Mohr circle and the analytical method to solve the stresses at some inclination from the original plane if the stresses in the vertical perpendicular direction are known. So please solve these problems. And now we are coming to more Coulomb failure criteria. So we will again come to the session where our first session get ended. So we will now take a quick revision of the second session. Afterward, we will start with the content which we are interested in discussing today. So now I am sharing the presentation for the second to take the revision of the second session. Afterward, we will start with a new content. In a 10-minute time, it will be over. So we will start with a new content. So this is for your convenience. Whoever is watching this video for the first time, either on YouTube, also will get benefited. That is my concern, and it will also enhance your concept because the double division takes place of the same concepts, one after the other. Okay, I think so. My presentation is visible to you. I think so. Okay, no problem. Give me a minute. So the Coulomb failure criteria. This is the basic criteria. Basically, in this case, we are talking about the shear strength. So shear strength is the function of sigma. That is the effective stress or the total stress as well. Earlier we are talking about the total stress. Afterwards, we have modified more Coulomb theory where we consider the effective stress because the pore water is so much problematic basically for our civil engineers when we are talking about geotechnical concepts, the water is the biggest problem for us. Water creates so much problem. It changes the effective stress to a very extent if water table get rose up. So we should be very careful while designing, while calculating the strength of any soil because due to those only the certain different types of failures take place in our day-to-day life. So this is the general relations and this is the representation that how this is the angle of internal friction, how the cohesion is known. There is a derivation is also there which will be coming in the subsequent slide and that will be discussed that was discussed during the last session. So the some definitions are there. So I am not going through those definitions because they are the basic concept. You can go again from your topic only. Yeah, the mathematical definition of the weak plane. There is a weak plane concept is there that what is the weak plane. We earlier in the first presentation as well, I have told you that see that this is the parent body and detached body. So that is the basic aspect that body is get detached from a certain place, and this is happen only because that is the weak plane and the weakest plane because the failure doesn't take place just from one point. Whenever we say any failure, specifically if we talk about in a hilly region slope failure, the soil get detached up to larger extents, and this happen only because that is the critical plane over there. From those plane, the strength is at its lowest level. So be understood those points. That is the basic aspect. That is the basic concept you need to understand. Okay. So now the factor affecting the influence of shears. So the some of the major factors like earthquake and other factors like slope instability, construction activity also lead to the failure of soil in shearing. So those factors are also you need to understood, and I have also given the homework during the last session whoever are there during those that interaction to write those factors. So that will help you to understood the concepts. Now the application and significance. We are talking about the application and significance. So earlier also I have told you that application and significance is one of the most important aspects. So in geotechnical engineering in day-to-day life, shear strength is the most important significant point of thing, and it will have a major application in the constructions of foundation, slope, and retaining walls. So it has a very good applications all over. Now we are talking about the shear strength of soil. So we calculate the shear strength of soil by a different technique. Like there are different methods are there, like direct box method, triaxial method, vein shear test. So those we have discussed during this session, and I'm going very quickly for that. Basically, I'm running out of time, so I'll not take too much time to explain these points. But I think so. A little information will be shared, so that will help you in moving ahead with the new content for you. Okay, so the more column criteria you must go through the presentation. If you are not there in the last session, if you are there as well, you must go with those content that will enhance your concept, like anything. Okay, so now we have talked about the more failure criteria in the last test, and we have talked about the several tests, specifically the shear box test, triaxial test, Venn test, torsion test, blackjack test, and the penetration test. During the last session, we have studied how the shear box test happens, how the predefined plane is there. In triaxial test, the 3D implementation, the actual implementation is shown. We also talked about the Venn test, torsion test, blackjack test, and penetration test. Today, we are going to discuss the vein shear test in little detail as well. So some of the input of the triaxial test, some fundamentals related to geotechnical engineering, like the permeability and consolidation settlement, is also taken into account during the content which I have prepared for today's discussion up to a prime extent. So we have studied how direct shear test, what is the apparatus, and over here the box is written at 16 to 60, but it is not always. Whenever the we are doing for the research purpose, we vary the different consideration, so we'll get the value, because in research we are doing research. So during the research we vary the those aspects, so find what is going to happen actually. Basically, it is not always the case, but for normal purpose we are using the box of 16 to 60, and this is a typical representations, and the steps are written over there. What are the conditions should be there, what type of sand, what type of soil should be there for the each test is also over there, and the procedure of test is mentioned. I am not going in those details, and due to the time constant for today. Okay, the advantages and disadvantages are also there. That how it is advantages and what are its disadvantages. One of the main disadvantage that we already know the failure trend, that from which section the soil gets failed, so we doesn't get the critical point from which the soil gets failed in actual, if it is over there at the site. So this is one of the biggest disadvantage, and there is also that there is no pore water pressure measurement is there in the direct shear test. But when we go in the triaxial test, there are different UUs, U and CD test. So in those cases, the pore water pressure measurement is possible. So we can get the effective stress and total stress parameters from those calculations. So this is the triaxial test apparatus informations, and this is the schematic diagram which is representing the triaxial test apparatus, and test procedure is also mentioned line by line, and it is discussed in very detail during the last session. There is two stages there. This is most important. Or during the first stage, the confining pressure is allowed, is applied, and during the confining pressure, the pressure from all the sections is remain uniform and is mostly applied through water. We can use some other lubricants, fluids as well, but in general, we are using water for application of the confining pressure. In the second stage, the deviating stress is applied on the basis of, and the sigma. When we are talking about the confining pressure, it is normally sigma 3, which is acting all around, While when we are talking about the deviating stress, it is acting from the top, and from this also we can form the more Coulomb failure envelope. In that case, how the Mohr Coulomb failure envelope get created? Like we apply the value of sigma 3, then we apply the value of deviating stress, and the deviating stress is nothing but the normal stress, like sigma 1 minus sigma 3. So for every sigma 3, suppose we applied the value of sigma 3 as 20 kilonewton, we get the value of some value of sigma 1, and afterward we apply the value of sigma 3 as 21, we get another value of sigma 1, and subsequently the result get processed. So on the basis of that, the different circles are drawn, and those circles are only drawn from the top side of the XY axis, like tau sigma plane, and when we draw a common tangent to that, we get the value of more failure envelope, below which there is a no failure takes place, while above which, if the certain point above those envelope, so the failure takes place. That diagram is also there, and that is discussed. Some of the more diagrams I will show you. And the three type of test during this is the UU test, CU test, CD test. So these are the some of the tests which are very important consideration in our aspects. Moving ahead, what are the significance of this? How the pore water pressure could be calculated? That will help in our calculation. What is the advantage of this test over the direct shear test? Those points are also mentioned here. Please go through that. And the total stress parameter and the effective stress parameter, the both test is analyzed and elaborated over here. From here, how we get the value of tau, CUU, and CD. When the tangent value is parallel to x-axis and when the tangent value is inclined at certain angle is also discussed in a very great detail. So I am not going with that. I will discuss these points again in a subsequent week because those topics are again coming in our consideration. So I am not taking those aspects, but in last week also I have discussed in very detailed manner. So I am not taking time on that because I have some new content to discuss with you. Okay, these are the some correlations relating the value of sigma 1 and sigma 3 and specifically the parameter like the frictions and the cohesion for the triaxial test. So these are the very important correlations from which we also going to solve the problem in a next week. Okay, so and now we at the last during the our last discussion we have studied about the Scampton parameter like what is the value of A and B because we are talking about the poor water pressure and we have tell that the poor water pressure could not poor water pressure can measure during the triaxial test which is not happening during the direct shear test. So those discussions are over there and how we calculate the total pore water pressures and during the different test when the E value is 1 and when the B no, sorry when the B value is 1 and 1 when it is 0 is also there like during the saturated the value of B is 1 and during the unsaturated it is 0 and how the value of A vary is also over there. Okay, I think so. Up to this only we have discussed during the last session. We have talked about the relative density as well. We have told that if the relative density is more than 67%, the soil is dense, while if the relative density is less than 30%, it is a luge. So those considered on the basis of relative density, we can relate. We have talked about the void ratio for a fine soil, but for the coarser soil, the relative density becomes most important thing. We also relate with the dry density. So those aspects are there during our last discussion. So and we have solved some problem as well. Now I am going with the aspects which I am interested in discussing today at a larger during in a larger picture for you. So I will start with that now because I think so. Whoever are there to join are there, and who are not there can see this content during at YouTube during the after I have uploaded over there. Okay, so now I am going with the new aspects. This revision must be helpful for you. You can tell me by commenting either in YouTube or anywhere else wherever you are seeing it. If you are not here, I think so due to some other commitments. Okay, so now I start with this content and we will discuss this slide by slide and in a little slow manner. Basically, up to this time I am going very fast, but now you will not feel too much problematic in understanding anything. But as of now, earlier also you have understood in a very good manner. If you have attended last two sessions, then it's no problem for you. If you are not there, also you get the some of the background which will help you in understanding these points. So we are studying the geotechnical engineering too, and this is the week three content, phase contents. And first of all, I have represented a diagram over here. You can see that the how the resistance is providing and how the failure takes place. Basically, the detached body and parent body. This is a picture of structural foundation in which we are showing the load from the structure get transferred to the ground and how the resistance is offered and how the stress get transferred is represented. This is a not a this is only a schematic diagram. We will elaborate those points up to a larger extent as well in subsequent classes. So the soil shear strength is the ability of soil to resist the sliding along the plane or a shear force. Basically, this definition never mentioned during any of the slides. So I will try to put some new points so that will help you. Now, what are the factors? When we talk about the, as I am going ahead with some of the fundamental concepts today, along with the Bayesian test and some of the aspects of the triaxial test as well. So we will again go with some of the fundamental aspects, and these points are very important. Like what are the factors that affect the strength? So first of all is the soil type. that what type of soil is there, whether it is a clay soil, whether it is a gravelly soil, whether it is a sandy soil or a silty soil. So soil types become very important during the calculation of the shear strength. And depending upon the type of soil, when we have gone through during the last session, we have discussed the triaxial test. Over there, we have seen that for different type of soil we perform. Specifically, if you are talking about the triaxial soil, like for which type of soil we are performing UU test, for what type of soils UU test and CD test respectively. So that only depend on the soil type. Basically, we are interested in getting the results. As UU test is the first test, so we get the result. And over there, the water is not allowed to flow out, so it is resembles the clay soil up to extent. So those things need to be understood. So I am putting these points over here so I can relate the past aspects with you, so that will enhance your understanding about the topic. Okay. Now, what can basically moisture content, when we are talking about the moisture content, so water can act as a lubricant and reduce the friction between the soil particles. Whenever we are talking about the basic aspects of the shear strength, we say that S equal to C plus sigma and tan phi. Over there, phi is the friction angle. So water act as a lubricant and it will reduce the friction, so the value of shear strength also got changes. So the moisture content is also one of the aspects that affect the shear strength when we take the larger picture. Okay, and it will ultimately reduce the shear strength because it will reduce the value of friction between the soil particles. Now, when we talk about the excessive effective stress, we have considered the effective stress, not the total stress. Why? Because when we say that talking about the effective stress, we consider the value of water. We have considered the water table, where the water table is there, and how the variation of water table result in the change of the value of stresses at a certain sections. So on the basis of that, we are going to calculate the strength, and that strength will be the desired strength of the soil that will help you to find then that how much load you could apply because the failure of soil is shear. Okay. So the stress imposed on soil due to the external load affect the shear strength at which the soil particles interlock. There is a new interesting thing like temperature. Earlier, in any of the slide, we haven't mentioned about that whether temperature also affect. But the temperature also affect. Like changing the temperature can affect the physical property of soil. You can see that at different places, at different environment, specifically if you go in a hilly region, if you go in a plain region, if you go at a colder places, the soil property also get varied from place to place depending upon their environment, their temperatures conditions. So that is also one of the aspects, but it is not in a so much concern for the geotechnical engineer, but it will also one of the aspects that need to be think of by the geotechnical engineer. Now we have different testing method. We have discussed about the direct shear test and the triaxial test during the last discussion. Direct shear test we have discussed as a box test. So over there, we have discussed that how the direct shear test is performed and what is the problem with the direct shear test. Like we are not able to calculate the pore water pressure, and we also came across the triaxial test. Then how triaxial test get performed. What is the process? Like in stage one and stage two. Stage one is the confining, and stage two is the deviatoric state. So, and how the different condition of allowing the water to flow out or not allowing to flow out will help us in getting the value of the cohesion and friction angle. So, that is the aspects which we have gone across during the triaxial test in a very good manner during the discussion. So, I will come to the third, which we have just read and go ahead. So, I will discuss this point of the field shear test, and specifically shear test, that how it is performed in our day-to-day life, how we will get the value of the shear with the help of shear test, what are the correlations relating the value, how we will perform this test in lab, those steps also I will discuss up to extent during this session. So in a field vane test, a handled vane device is used to measure the torque required to rotate the blade in situ, which can use to calculate the soil shear strength. And when we again, I will read triaxial test and diaxial test for you in a very confined manner, which is written over here. Like triaxial test, a cylindrical soil sample is subjected to the confining pressure, which being compressed axially resulting stress strain data is used to calculate the shear strength. And soil sample is placed in a shear box and subjected to constant normal force. There is a mechanism very clearly shown during our revision session. Also, we have seen that there is a load is applied vertically, so it will get filled. We remain increasing the load step by step, and at one state it gets filled. So those aspects we have taken in a very good way. Okay. Now moving ahead, now we have a type of soil failure. There are the different type of soil failures is also there, like general shear failure, local shear failure, punching shear failure is there. Over here, the splitting is nothing but the punching shear failure, and the creep deformation. Creep deformation is mostly aspects we talk about during our the strength of material session. But with time also, due to specifically if you are talking about the clay soil, with time there is some water get released from the ground surface. Due to that, the deformations takes place. We have talked about the consolidation and settlement. We also take one of the interrelation relating the elastic settlement, which takes place immediately after the application of load or during the construction only. That we talk about elastic settlement. The relation is like that settlement is equal to QB into 1 minus mu square into IB by ES, where B is the width of foundation, Q is the applied load, and IF is the influence factor that depend on the dimension of the foundation, specifically D and L. And the another aspect mu is the Poisson ratio, E is the modulus of elasticity. We will take that. And you can solve some problem also on that topic that will help you. Okay. So when we talk about the types of soil failure, so general shear failure, when we talk about general shear failures, it takes place when the relative density, specifically in dense sand, when the relative density is more than 67%, it is seen that the general shear failure takes place. While when we talk about the local shear failures, it takes place when the value of relative density get reduced to the 30%. And we can also relate the value of phi for general and local as well. For phi value greater than 36 degree, the general shear failure takes place, and for less than 28 degree, local shear failure takes place. And the splitting the punching shear failure mostly takes place during the deep foundation. In shallow foundation, this type of we will read those specs during the foundation engineering in very detail. And the general shear failure, local shear failure, load transfer mechanism in a shallow foundation and deep foundation is one of the great aspects which need to be understood by the geotechnical engineers, specifically any civil engineer who is working in the field of geotechnics. Either you are the undergraduate student or postgraduate student, the types of failure and the load transfer mechanism is the most important criteria to work in any organization if you are the working professional. So this basic concept need to be understood. Moving ahead, application of shear strength analysis. We have already studied several times that from the foundation engineering, from the foundation design only, the shear strength becomes the one of the greatest aspects. So if we want to design a stable and safe foundation for any superstructure, so the soil shear strength and stability is one of the most important criteria. If we are taking the analysis of the risk of landslides, the slope stability analysis become the one of the most important factors, most important concern for the civil engineers. Similarly, the earthquake is also a bigger problem in specifically in last few days month. You have seen about there is so much rainfall. Sometimes the cloud get rusted and so much water's flown like river. Specifically in Uttarakhand, you have seen if some of you from if any of the IIT Mandi students are there, they are seeing that there is so much devastating effects take place in the Mandi only, which is one of the good have a good infrastructure over there. But due to the so much rain, only this will take place. So believe that when the earthquake happens, and in India there are the critical earthquake zones are also there. So during the earthquake, there is a huge problem can arise due to the value if we doesn't consider the shear strength up to a greater extent. We doesn't understand that how the soil shear strength affect the behavior of soil during the shaking, during the dynamic loading when it comes on the ground. Okay, so these are the applications where we apply these concepts. Now, how we analysis. So this is the some of the broader aspects I have written for you during the introduction. which we are not doing during this coursework, but for your understanding only I have written this. Like the finite element method is one of the powerful tool. Any of the researcher you have seen whenever he go for the either the lab work, or mostly if some places the lab work is get tricky, so we make a finite element model where the model is created and the conditions which is there on a site is implemented, and a message generated message, like we divide the entire structure in the small elements, and each element's analysis takes place individually, and then the result is compiled over here. If you have any of you are the PG students, if you have gone through the finite element, there is a method like Rayleigh method, weighted residue method, and the weak formulation, variational formulations, Galerkian approach. So those approaches are there with which we calculate with which the calculation take place in background. We just model that. But if any one of you are using any software, what is the background of that? How the analysis takes place? What is the boundary conditions? So you need to understand about that as well. So basically, what I have deviated from some point, like in finite element analysis of the sub of the structures, we mostly are concerned about that how the structure get behave during the earthquake. Because the earthquake is whenever we study, we couldn't apply. We could apply manually, but that will be expensive as well as time consuming. And at some point of time, the creation of models, physical models, quite difficult. So we perform the finite element analysis, and over there we study the smaller elements, and these elements interact with each other under the various conditions, providing the valuable insight into the material. We provide the conditions like what is the material over there, what type of soil is there, what is the value of cohesion, what is the value of friction. So that will given to given to the soil property and the material property which we are implementing during the designing. We also can implement the dynamic load, as well as if some wind loads are there, some earthquake loads are there, we can implement over there, and then our analysis and run, and on the basis of the output of result we could gather that this things, this type of strength over there, this type of structure could sustain, and what are the changes which we are required. So that will be quite helpful in simulating the different problems over there, and found predict the make a prediction that this place behave like this. Okay. Now we talk about the constitutive law for material behavior. So, constitutive law for material behavior is creating the relation of stress and strain. It is either shear stress or shear strain, or the total stress or total strain. So, over there you know the a simple relationship relating the value of shear stress with a strain, like tau equal to E into strain, where E represents the elastic modulus of material. This equation significances that the stress is directly proportional to strain, reflecting the linear behavior of material under the small deformation. When we talk about the finite element simulation, the constitutive law into the input computer program duplicate the real world material, and that will give the result. This is the broader aspects, so don't worry about these as concepts up to a larger extent when we are talking about geotechnical engineering too. This is the broader aspects I give you, like if any one of you have the understanding of the finite element method, so you will get it to the more extent. Others should also get the basic about idea about that. Now, when we talk about the behavior of stress strain graph, there is a curvilinear behavior is seen during the stress strain graph, and there is a one graph is also discussed during our last discussion over there. And the variation of stresses is shown, variation of y ratio is shown for the dense soil as well as the loose soil. So when a material experiences the larger deformation or the higher stress, their behavior become more complex. The stress-strain relation deviates from the linear behavior, resulting in a curvilinear graphs. And the concept of failure in develop emerges represented like tau equal to A into sigma by B, where the tau is the shear stress and sigma is the normal stress, and A and B are the material constants. So these are the interrelation which could be developed with the help of analysis. So those points are there. The constants vary based on the analysis types, total stress, effective stress analysis. We have studied the total stress and effective stress analysis during the last session, during the revision session of week 2 also I have represented. at the effective stress parameter and the total stress parameter. So those understandings are equally important to understand the broader aspects during our analysis. Either we are doing the physical model test or the finite element model test. Now, stress dependent shear strength parameter. So what are the stress dependent shear strength parameter? We also need to understood. So first of all, and the shear strength parameter, the two of the shear strength parameter is like the cohesion and the value of friction, internal friction. So these are the most crucial because from the first lecture only, from the first two, three slide only, we have talked about the cohesion and friction angle, cohesion and friction angle. So it is the most important aspects when we talk about the stress dependent shear strength parameter. So they vary based on the stress range and the material subjected to, on which type of material they are subjected. Like if we are talking about the aspects of the strength of material, so their material is hard, they have also have elasticity. So over there the behavior is different, but when we talk about the soil, so its nature of material changes, so its responses also got changes on those aspects. So the transmission from the frictional to cohesion behavior is also one of the things. And the dynamic nature of C5 soil, like when the dynamic forces act, like we have studied that during the geo earthquake, what are the conditions that could arise which will affect the study, and the different stress ranges call for the telluride parameters ensure the accurate predictions and the safety net. Now, transition from the frictional to cohesion behavior. Earlier, I have mentioned that the transition could take, but how this transition took place, those some points are mentioned over here. I will read for you and elaborate as well. So the material subjected to increasing stress experiences a fascinating traction in behavior. Initially, the frictional in response and the material gradually transform into the cohesive material under the higher confinement. We know that when you talk about the cohesive soil, we see if you have gone through the core cutter method, if most of you are the UG student, if you have gone through the lab, so during the core cutter method, we say that this will take place in the soft soil with the some cohesion. If there is a no cohesion, when we insert the core cutter and if we remove the soil which is over there doesn't remain there, you must have gone through core cutter during your the geotechnical engineering one course. Basically, from that we calculate that what is the dry density and what are the steps you must have understood. But I am explaining from there only. So how the cohesion is important. If not, if the cohesion is not there and we are performing the core cutter, the soil get fall from there. So there is no aspects that we are getting the result for the dry density. That's why the different tests are there from which we calculate the value of water content and the dry density during our study. Okay, so cohesion is very important parameter and it will ultimately give the strength. When we talk about the cohesion and angle of internal friction, cohesion is most important parameter which ultimately reflect in the strength. Okay, so the transition from so during the higher confinement, the cohesion is very high. This transition from friction dominated to the cohesion dominated behavior is a vital aspect of the material mechanics. Basically, due to the application of load, the higher stresses, the confinement get too much strength and the like it will become the cohesive in nature from the fictional dominated nature. So from this specifically, if you have, if not, you must have gone through the geotechnical engineering one course. Over there, you have a study about the optimum moisture content and the dry density (MDD) and OMC. So in a standard Proctor test and modified Proctor test or light compaction test or heavy compaction test, by whichever name you know those tests. So in that cases also we try to optimize by passing the different passes of rollers. So on a road, if during the highway construction or any construction. So understand this transition is vital in geotechnical design, where the stress level play a crucial role in determining the soil behavior. Accurate parameter selection based on the stress condition is a key to ensuring the foundation stability and overall project success. Okay, I think so. This will be clear. I will move ahead. So stress range parameter. Some more points related to that aspects only, like selecting the appropriate shear strength parameter involves considering the stress range of the project. Different projects have varying stress regimes. For example, embankment and foundation experiences the stress level different stress level compared to the shallow slopes. It must be there because embankment and foundation sustain too much load, either the load of soil or the load of water. But when we consider the slopes, the load over there will be of different type at different heights. So that must be different. And matching parameters to the stress range to ensure the reliable analysis and the safe designs. So the geomechanics, when we talk about geomechanics, so geomechanics, the study of the soil behavior under the different conditions, guiding guiding the parameters sections. This discipline allow engineer to adapt the changing behavior of material under varying stress scenarios. So this will become very important. Now the crushing and the particle behavior. Now we are talking about the crushing particle behavior. So at high stress level, the groundwork material undergo the particle crushing. If we increase the stress up to a larger extent, there is a crushing must takes place of the particle. So that will also one of the aspects which we need to understand, that how much confinement we are going to give if we are trying to convert from one state to another state. In a way, not always. Stress induced crushing of particle alters the material behavior and responses. So if we change the particles characteristics by crushing them, so its behavior also must get changed. You must have gone to the formation of soils. Over there also you have studied that how the weathering, how the transmission of hard rock from one place to other ultimately may also result in the change in the properties. So those aspects also get physical properties specifically. The phenomenon occurs in the specific zone on the stress strain curve and affect the material strength and stiffness. And understanding the implementation of particle crushing is crucial for the project involved, being load bearing structure. Proper consideration of the particle crushing zones is essential to prevent the structural failure and ensure the long term stability of the engineered structure. So these aspects need to be understood in a good way. Now we talk about the material attributes and the geomechanics. So in this, a material behavior is influenced by the multitude of attributes, including mineralogy, angularity, sphericity, density, and crushing strength. The attributes collectively defines how the material will respond to the stress and deformation, and the complexity arises from the interaction of these attributes. When these attributes interact with each other, when we correlate with each other, and the different aspects will provide the different result and ultimately give the understanding of the actual process which is going over there. Now, the material testing is necessary to assess the material behavior under the specific stress condition. The diversity of the material attributes require engineer to tailor the analysis and design approaches to each of the unique project. And everything is unique for each project. It will vary. It will be independent in a way. Now, material testing and its application is also important whenever we are going to do that. So, material testing is the critical step before utilizing the material engineering projects. Whenever we are doing any analysis, we first of all see the soil. Over here, the material is soil. So, we must perform some test over there. Just if we talk about the real life example, like if any athlete is going, first of all, if you see cricket, you must know about the yo-yo test is there. Over there the athletes, the cricketers, for if they doesn't pass the yo-yo test, they are not qualified to take to be there in the selection, available for selection. So just like athlete understanding the physical capability, see in the same manner understanding the capability of soil, at how much load, how much strength, and how the safety will be provided by it during the application of load, each one of the aspects. Now the is similarly in the analogy of sports is similar for the material when we are going through for the testing of this. Okay. Now composite material and future consideration. Over there, first of all, we conclude this session and conclude this section. After that, and then we go for the two of the test, like Vensia test and the tri-axle test. We will take some of the important aspects, fundamental of geotechnical engineering, and afterward we will see the aspects of the Vensia test, how it will be performed, and what by how we get the results, and how we get the factor of safety as well also understood, and the settlement correlations are also there. So composite material and future consideration, when we talk about the claim of geotechnical engineering, there is a growing interest in the composite materials. In geotechnical engineering, whenever you go, if you see the researcher, yes, the composite materials are becoming so much important these days. We are talking about the composite material. So by combining the different materials, engineer can create the composites with desired properties, and the composite material allow for innovative solution and can better address the challenges posed by a complex projects and dynamic material design. The future of geotechnical engineering involves pushing the boundaries of the material science to develop the innovative solutions that improve the sustainability and safety and the efficiency of the construction and infrastructure projects. So that need to be understood, that need to be understood by we geotechnical and civil engineers. Now I will give one of the conclusion and recap of this section only. Afterwards, also we have a section. I have divided in three sections for every section. After every section, I conclude and give some recap. And after this recap, you also take a small break of 5 minutes. Afterward, we will start again and continue our sessions. Okay. So I will read the conclusion and recap for you. After that, we will take the 5 minute break. So understanding the constitutive law, material behavior, and the parameters selection is essential for accurate geotechnical analysis and design. The dynamic response of material to stress ranges underscores the need for the tailored approach in the different projects. By recognizing the diverse attributes of the safe material behavior, engineers can make the informed discussions that ensure the project success, and the interdisciplinary nature of geotechnical engineering challenges us to believe the material science, mathematics, and the participation material to create the robust and resilient infrastructure. So remember one of the point, like the explanation with the relevant diagram will help us during this of our work. So I will take a break from here, and after that we will study the fundamentals of the geotechnical engineering and the triaxial testing up to an extent. So this is already 4:03, so we will start at 4:10. Up to that there is a small break. So please be remain in the meeting. We will start at 4:10. Welcome back. I think so. Audio and video will be clear for everyone, and from here onward, we will start our discussion, and we will end our session at 5 now. Okay. Let us start with the soil mechanics fundamental and tri-axial testing. Here you will get some of the broader aspects of the tri-axial testing. What are the different things which are considered during the tests, and what are the aspects we need to understood during our study of the what are the aspects we need to understudy during the tri-axial testing? The aspects of the fundamental soil mechanics, like we see that consolidation, or different type of settlement as well. Elastic settlement also we go across, and how to relate the stress and strain, how during the consolidated and unconsolidated tested the different parameter like stress and strain behaves. Those factors we will look into that. Okay, I think this will be a good time to again go ahead. Okay. So first of all, I will start with introduction. Then I will do different sections. So, in the field of geotechnical engineering, understanding the behavior of soil under the various stress conditions is crucial for designing the stable structures and foundations. And shear strength is one of the fundamental parameters. During this presentation, we will focus in the selection of the shear strength parameter, which underline the concepts and the significance of the triaxial testing, characterizations, and the soil behavior. And now I will discuss some of the point one by one that will vary in a good elaborated form I have made for you. So during your revision also, if you go through these slides, the content are so organized like you will easily get remembered, and the aspects also I think so you will find very interesting. Okay. So first of all, the shear strength and strain behavior. So first of all, we talk about initial behavior. So imagine a spherical particle under the compression. Initially, it tolerates the stress within the elastic range. After that, the breakage and crushing takes place at a certain point. After the, if you apply the stress at any point, either it's some material like during strength of material, we talk about the steel. On that also we apply the tensile stress. After a certain extent it will bend or a necking will fall, and a fracture point is also there after that. So similarly, if we consider a spherical particle and we apply a compressive force on that, so up to a extent the it has strength, it will tolerate its it will tolerate to get compacted, but after a beyond a certain point, a breakage and crushing can occur, leading to the changes in the particle shape and sphericity. So, this will ultimately the lead to the change in the property. Physical property gets changed over there due to that. So one of the aspects afterward what takes place like interlocking effects came in progress. In interlocking effect, as the particle become irregular and the interlocking effect emerges and affecting the compaction ease, and afterwards the cohesion and interlocking will act, and that will increase the irregularity, enhances the interlocking and leading to the more cohesive soil behavior of that spherical particle, which is initially have inherent strength to resist the some of the compressive stress. So how this stress, shear strength and stress strain behavior takes place will be seen with this implementation. Moving ahead, when we talk about the density, when we take the density and shear strength side by side, so the shear strength is must be depend on shear strength graphs are the density and density dependent. And when we talk about the cohesion versus friction, the shear strength increases due to cohesion but not friction. We have already understood like the cohesion is the prime parameter that will result in the enhancement of the shear strength of the soil. I don't say that friction has no role, but it has less role as compared to those. Because I already given the example, like the frictional soil by compacting up to extent, you will get the value of you will get the value of the shear and you will get the increased value of shear strength by increasing the cohesion of it, those particles. Now, the two component strength is also there. The shear strength arises from the interplay between the cohesion and the friction. The C5 soil is also there. So the cohesion and friction both imparts ultimately, if we say if we know the relation of the shear strength, we say that S equal to C plus sigma and tan phi. So over there, cohesion and phi both are there, both play the important role. It is another matter during the solving problem, or we can neglect some of the aspects. If the soil is wholly clay soil or only friction soil, it is not like that. There is no friction will be there. There is negligible friction, but that will not implement. That will not affect the ultimate result. Ultimate result that is showing the strength. That may be one of the factors, but it is, could not say that either it is a completely clay or it is a completely sandy soil, it is a completely sea soil or completely five soil. So that is one of the aspects. Now we talk about the variability, soil behavior. That's how soil behavior vary. If we talk about the sand and clay, and then we take the aspects of cohesion and friction. Those go by hand in hand, but I will explain this point for you. So general soil exhibit varying behavior, and varying behavior are under the different stress conditions. When we talk about the cohesion and friction, it is not limited for the specific type. Like uh, for sand only showing frictions, while clay only showing cohesion. So this point need to be understood. If it is a completely clay soil, so cohesion is the prime aspects which we are considering to calculate the shear strength at those sites. Similarly, if the friction is predominant, so friction takes place in command. So that need to be understood. Okay. Now the tri-axial testing and the stress tests. So we know that we have studied the direct shear test, tri-axial test, and during tri-axial test we also relate the value of sigma 1 and sigma 3 with C and phi. So those aspects first of all we go across. So in direct shear test, use of soil responses and characterization takes place. We already know that this is the soil, this is going to fail from here, the pore water pressure dissipation could not be calculated, but we are performing to get what is the value of strength, and it depends on from where we are performing the test and what type of soil is there, what important structure we are going to construct on the basis of those results. We could use the different type of boxes for the test. So that is the one of the aspects. But when we talk about the triaxial testing, it incorporates the state of stress to which the soil is exposed. And when we talk about the stress conservations, changing stress state affect the cohesion and the angle of internal friction. So if we change, suppose the value of state of stress like cohesion and friction get changed, the value of sigma and phi also get changed. We can relate this with the simple triaxial test equation like S equal to sigma 1 equal to sigma 3 tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. Over there, you could observe that if the value of C and phi got changed, the sigma 1 and sigma 3 get also affected. Converse is also true. Means the sigma 1 and sigma 3 value variations in different proportion lead to the change in the value of the stress parameter like C and phi, shear strength parameter. Similarly, now talk about the texture, friction, and cohesion. What are the effect of those things in the soil. So in the fine grain soil and coarse grain soil, there is a two aspects. In fine grain soil, texture is governed by the pore structure and influences cohesion. While in specifically if you are talking about the fine grain soil, we are talking about clay or maybe silt at some extent. But when you talk about the porous grain soil, the particle property like shape, size, and specific gravity determined by the behavior, how it behaves. Because in those cases, the particle slide one over another and the friction will act between them. So that will, in a way, is providing the strength, shear strength to a certain extent. Okay. Now, the time dependent deformation is also important. So, in geotechnical engineering, we are more inclined toward the consolidation settlement. You must have gone across the consolidation during the course of soil mechanics or geotechnical engineering one. In that, you have studied that we could calculate the consolidation settlement. Over there, you have find the value of CV, like coefficient of consolidation, MB, coefficient of volume compression, and the different parameter like compression index, recompression index. You have also gone across. So from there you have find the value that what is the value of settlement. If a specific at a specific section soil is there, what is the settlement would be there. How we calculate the consolidation settlement. The different drainage condition also affect the value of the consolidation settlement in a soil. So those aspects are there. And another, if we talk about the consolidation settlement only, when we consider the different type of soil, like the one is clay soil and another is sandy soil. We know that the pore water dissipation takes place very faster in the sandy soil. So over there, the consolidation takes place faster during the construction time only. But when we talk about the clay soil, the consolidation takes place in a very long time. It is a very slow process. It will takes 80 to 90% consolidation. It will might be take 100 or 200 year or many more years. So those aspects need to be understood that what is the settlement ultimately going to take place, because settlement is one of the important criteria. You have seen the news of the Josimat some time back, specifically 6 7 months back. Over there, you have seen that cracks is getting developed in a building. So this is also takes place due to the differential settlement over there. Otherwise, the cracks should not arise in a walls over there. So you need to understood about the settlement due to consolidation as well. Now we talk about the cliff. So the long-term deformation due to constant stress, especially in the fine grained soil. This is only I have already told you that like the deformation which takes very large time takes place only in a fine grained soil like clay soil, silty soil. The water couldn't flow very easily from that, so it will take the very long span of time to get settled whatever the extent it could be. So it is a one in a way the time dependent. So it will maybe related to creep, but it is a consolidation settlement only. But we can say that if we are talking about the creep word in geotechnical engineering, it is for the fine grain material only. Because in coarse grain soil, the water gets dissipated ultimately and the settlement takes place during the consolidation. It's only mostly if we talk about the primary concentration due to the expulsion of pore water. Okay. Now the triaxial testing the plane stress versus three-dimensional stress. So this is the one of the point you must need to understand. And what is the need to understand these things is also one of the important aspects. So okay. So first of all, you see that the triaxial testing the plane strain versus the three-dimensional strain. So in plane strain, the strain perpendicular to the system are negligible. Basically, in a third dimension, we neglect the strain. Like if you are telling about the plane strain, the strain in x and y direction and x and z, x and y direction and xy direction you will be taken into account. The all strain associated with direction is neglected. Similarly, if we are talking about if we talk about stress during the plane strain case, so the stress in the third direction, like if x and y direction are the direction when we are talking about, we are neglecting the strain in the z direction, but the stress in the z direction must be there. And when we are considering the plane strain, if you talk about some of the example, the retaining walls, the dams, over there the third dimension is very large. That is the plane strain cases. Another example is water flowing in pipe. Sorry, so that are the some of the examples if we are talking about the plane state. But when we talk about the three-dimensional, to the more realistic but complex and expensive to recreate in lab, we know that for the three-dimensional, it is expensive as well. But in our triaxial test, we also relate sigma 1 and sigma 3. We say that the sigma 2 and sigma 3 is same, but we are implementing the practical life implementation only because the stresses acting all around is almost same, so it resembles the true state of stress at site what we are dealing over there. Okay, now the volumetric deformation. When we talk about the volumetric deformation, the in triaxial loading and in the consolidation loading. During the consolidation loading, the unidimensional loading assumes epsilon 2, epsilon 3 negligible. While in the triaxial loading, the triaxial stresses conditions are there. Moving ahead, the Poisson ratio and coefficients confinements are also equally important when we talk about the triaxial test. So in the plane strain versus triaxial, plane strain has a higher Poisson ratio due to less confinement. It will be very sorry. Okay, allow me to take some water. Okay, now we will proceed ahead. So over here, what we are talking about the significance of triaxial testing. That what is the significance? Why we are so concerned about the triaxial testing? So the cylindrical samples are there, and actually, if we go below the down, we see that the triaxial actually it resembles the actual condition what is over there inside the soil. So the triaxial testing uses cylindrical samples and symmetry will occur about the center of those cylinders like by providing the confining pressure, so accuracy get enhanced. And when we talk about the soil versus the concrete testing, the geotechnical engineers focus on the intermediate behavior, unlike the concrete testing. In concrete testing, we perform the failure takes place, we say that this is the given value. But in the geotechnical engineering, specifically, anytime if we are talking about any of the cases like consolidation or permeability, we believe that what will take place with the time, not the sudden result will be implemented. So it will take the time taking process. If we take the example of the tri-exit test only, when we perform the different like UU, CU and CD test, the different test takes the different times to get the result. So that need to be understood by all of you. Now, up to this section, I will conclude like the fundamentals of geotechnical engineering and soil mechanics. I am concluding over here. After that, the vein shear test is the one of the aspects we will go with that, and up to that we will go into in our sessions. We will also show you some of the interrelations and some of the more works. I will suggest at the end that if you go and perform at your home, you will get benefited. You will get the better results. So the understanding the shear strength and the soil behavior, understanding the different type of stress conditions is the essential for the safe and effective construction of project. Basically, when we are reading this section, we come to know that if we understand the behavior of the soil, what will be the strength, how it will behave, we came to know that what is the essentiality which need to be provided to be the safe during the adverse condition when the shear failure takes place, and what should be the load should be there in any adverse condition as well, because we are constructing the different type of structures, maybe institutional building, maybe some important infrastructure project, maybe some of those projects which might be of the national interest. Over there the safety concerns is the most important things. So those aspects need to be very and broadly understood to know the what type of load and what is the shear strength of soil. Another important aspect which we came across in this section is the triaxial testing provide the insight into the complex interaction between the cohesion, friction, and the stress states leading to the better designed foundation and structures. So these are the some of the aspects which we have understood. Now we will go to study the Bayesian test, and it is also one of the important aspects. In this also we find the sum of the interrelation by which we calculate. We also I have also mentioned the study procedure test procedure for you, so it will resemble you. And with this, before starting this, I will tell you that please perform this Bayesian test at your respective institutes, or if it is possible, if any one of you are the working professional and doesn't have the access to lab, so please see the demonstration of this test at YouTube by over there. The NCTEL is one of the channels, that is the government of India channel like NPTEL. So over there you will find the so much important testage, so that will give you the good perspective, and those tests are performed in a very good manner, in a real manner. So you will understood those things as well. If you don't have access of laboratory, if any one of you or all of you have access of laboratory, please perform in the lab itself. So it will give you better idea. Okay. So first of all, the Bayesian test is a valuable method in accessing the shear strength of the sensitive soil, striking. Uh, and give me a minute. Am I audible? I think so. I am audible to you. Okay. No problem. No problem. I will go ahead with this only. I think so. Audio and video is clear. No problem. I will go ahead. Okay, so the Bayes shear test is a valuable method for addressing the shear shear testing, in a valuable method for accessing the shear strength of the sensitive soil, striking a balance between the 2D and 3D testing techniques. Basically, it perform a balance between the 2D and 3D techniques. And in this presentation, we are going to give the mechanics of behavior testing, its application, and insights its offer into the cohesive soil behavior. How it will perform on the cohesive soil. There is two types, like we insert the whole behavior inside the soil. Another is like the top of the it will kept at top of the soil, and there are two interrelations are also there. In this presentation, I think I have mentioned only one correlation. So that will be mentioned during the next class. I think by mistake it will remain only one, or maybe during uploading I will upload both correlations, so you can go across that. So first of all, understand the Bayesian test. What is the Bayesian test? How it will perform? So the Bayesian test is a method to measure the shear strength. It is the one of the method, like the direct shear test and the triaxial test, by which we are able to calculate the value of shear strength. It is providing a balancing between the 2D and 3D, like a middle ground between the plane strain and triaxial testing. It is the intermediate between those. In triaxial testing, we get the actual 3D condition, while in the 2D testing, plane strain, middle ground between the plane strain is observed. While in a third, the Bayes mechanism is there. In a Bayes mechanism, rotating a vane within the soil sample to mobilize the shear strength. We do that. We read the procedure step by step. Every point is there, but you understood the basic aspects first. Then we will go step by step of the test. So we'll get the better understanding of the topic. So first of all, we talk about the setup. How what is the setup? In the setup, the caging and sampler are there. In caging is inserted into the soil. It is used normally for the soft and sensitive sample during the testing, because if the soil is not soft, we couldn't rotate it. First of all, we have to insert in the soil, then we have to rotate, we have to provide the torque, and there is a relation relating shear strength, like T by pi d is equal to h by 2 plus d by 6, so or d by 12 also for one way and two way respectively. That I will show you. The correlations will be shown. I am telling just for the sake of convenience that the correlations are there between the torque and as well as the what will be the height of the sample and what will be the dia of the sample. Those are very important concept. Now, in vein rotation, loading a vein into the sample, as I have told you, and applying a torque for rotation. Laboratory and field testing, when we are talking about it is a laboratory as well as field test and adapted for both controlled lab conditions and offshore environments. For offshore environments as well, we could able to perform this test. Now, when we talk about the free body diagram and the cohesion mobilization, the vein configuration have a vein blade and the radius. This radius is equally important and this length is also important because we are relating the length and radius. We are not using diameter instead of radius, but if we know the radius of the vein blade, then we could correlate to find the strength. And with the help of this system, we could also able to find the sensitivity as well, which we are going ahead. You will see that those points very interestingly. Now the torque application. In a torque application, we rotate the vane around its axis. Around its axis, it get rotated, and the torque is applied by that mechanism. And in that case, the cohesion mobilization takes place. The cohesion mobilization vertically and horizontally. The soil, the mobilization of cohesion takes place in the soil over there. And when we talk about the cohesion mobilization pattern, there are some patterns must get developed like vertical, horizontal, or if it is inserted in the soil, some end bearing analogy will also be there. So when we talk about the vertical plane, the cohesion mobilized vertically due to the vane rotation because it is rotated about it is rotated about the axis. So due to this takes place due to the vane rotation. When the vane blade get rotated, this condition has been seen. Similarly, when we talk about the horizontal plane, the horizontal cohesion distribution for the soft and sensitive soil, the cohesion mobilization pattern will be seen in a horizontal plane for the in a horizontal cohesion. Similarly, if we talk about end bearing analogy to the end bearing in a structural piles has been observed. Basically, if we talk about the end bearing, mostly it is seen in the like D foundation. So the it will be a structural pile analogy is over there. Over there, this pattern has been observed. Now, solving the Valencia test. We are performing the Valencia test to reach to a certain result. We our main focus is to understand this the Valencia test and to obtain the result that will be utilized by us in our discussion, that will be understood by us in order to find the value of the shear strength. With the help of that, we are able to find the value of factor of safety in a similar manner. Like we have talked about the concept of the weakest plane. In a similar manner, if we get the value of the shear strength, then the applied stress is also known. If the whatever the strength divided by stress will be the factor of safety. So that factor of safety ultimately will help us to find those values. And with the help of this test, we are also able to find the sensitivity of soil, which is defined as UCS undisturbed means unconfined compressive strength of undisturbed sample by T star sample. So we will look into that as well in the coming slides. So first of all, the torque calculation takes place. The torque required for cohesion mobilization and the CV calculations is performed after that. And during the coefficient of consolidation calculations, the expression for CV mobilization in the vertical and horizontal plane, which we have discussed in the last slide, has been done. After that, there is a moment, basically torque is provided, and then with the help of that, the unknowns are found in the equation. Whatever the unknowns, basically the radius and length are already known. Torque we are providing is already known. So the correlation, that is T by pi d square into h by 2 plus d by 6 over there, everything is known, but Only unknown is the value of shear strength, so the shear strength get calculated with the help of range shear test. We will also discuss each step of this test in coming slides. So first of all, when we talk about Gaines shear test, okay, so I will again explore, elaborate those points that what is the need and what is the scope, what is the need of this test, and what are the scopes gets elaborated, get enhanced, get found with the help of this test. So the structural strength of soil is basically a problem for the shear strength. The vein shear test is a useful method for measuring the shear strength of clay, and it is a cheaper. It is a very cheaper method, very quicker method. It can take place. It can take very less time to calculate the strength, unlike triaxial test. So it is helpful as well in that way. And when we talk about the laboratory main shear test measurement, the shear strength of the cohesive soil is useful for the soil of low shear strength less than 0.3 kg per cm square, for which the triaxial or the unconfined test cannot be performed. So over there, this test can be performed. So this test will serve the purpose for the calculation of the shear strength. Over there, basically we primarily use the direct shear or triaxial test, but the Bain shear test also serve the purpose over there as well, where those tests are not sufficient to give the desired result. The result, basically we couldn't able to find the result over there due to the site constants or maybe some other reason. So this test gives the undrained strength of soil and the undisturbed and remodeled strength often are useful for evaluating the sensitivity of soil. Whatever I am talking about sensitivity, you will see the correlations of sensitivity as well, which I already specified. Some of the equipment which we use during this test is also one of the aspects. And give me a minute. So, what are the equipments we are using during this test? Is one of the aspects. The equipments are the veins here, apparatus, and soil specimen, specimen container, and the capillars. And in this test, I think so audio and video will be clear for everyone. Okay, so in this test, the experimental procedure will be there. So I will explain the experimental procedure one by one for you. It will help you. So in experimental procedure, first of all, we prepare the 2 or 3 specimen of the soil sample of at least 37.5 mm dia and 75 mm length. Basically, we try to keep the L by D ratio as 2 or 3, and mount the specimen container with the specimen on the base of the vein shear apparatus. If the specimen container is closed at one end, it should be provided with a hole of about 1 mm diameter at the bottom, and then gently lower the shear base into the specimen to the full length without disturbing the soils. A specimen, the top the top of the vein should be at least 10 mm below the top of the specimen, and note the reading and angle of twist. In the same way, when we provide rotation, it will be 0.1 degree per second rotation will be provided to give the torque, and the application handle until the specimen stays, because afterwards we will able to get the value of shear strength. So note the final reading of the angle of twist. Find the value of blade height in cm and find the value of blade width in cm, and afterwards you can calculate the value of shear strength at T by 2 pi d square h plus 2 plus d cube, and this will give the value of the shear strength, where T is the torque in cm kg. You can convert the unit in all unit in SI as well, and you can find the result. But over there I have given in the same way as it is discussed above, and with the help of that you will find the result. And apart from that, the one way shear, two way shear, some correlations are also there that will be implemented in the results before uploading presentations for you. So the factor of safety, now we are calculating the shear strength. So we must have some aim before behind the calculating these factors. So our aim is to calculate the value of factor of safety. So value of factor of safety will be found. So how we could able to find the factor of safety? So we found the value of topic. Basically, we are rotating, and at certain point the specimen will get filled. So the topic is that value, and afterward, whatever the factor of safety we want to apply. Suppose for 300 is the peak value. Suppose and 300 units, yeah, taking only units. Just for example, this is not the practical implementation that how much strength will be there. This is an example. So if we want the factor of safety of 3, so we apply only 100 units of load. We say that we apply only 100 units of load, so it will be safe 3 times, because it can sustain 300 unit of load, but we are applying only 100 units. So in any adverse condition, suppose during the cyclic loading like dynamic loading or the earthquake loading, our structure will remain stand at that places without affecting the structures which are situated over there. So those aspects we are calculating. The factor of safety will be specified by us on the basis of the importance of structure. If the structure is important for us, so we will be in that consideration to understand those things. Okay. Now, what are the advantage? Some advantage must be there for the fancier test. If we are performing this fancier test, some advantage should be there. Otherwise, why we perform these tests? We already have the direct shear test and triaxial test. So, it already said that it will be the intermediate between the 2D and 3D in the between the plane strain and triaxial. It is the intermediate, give the intermediate result. Sorry. So, this will relate those things up to a extent. So the dual equation obtained by the representing the test by providing the CV value and heterogeneous soil handling layer of soil scenario with the multiple equations is provided this test, and the sensitive soil analysis could also be performed. Sorry. When we talk about a sensitive soil, we can take the soil like soft soil or highly sensitive soil or quick clay soil. So those on those soils, this test can be performed and give us a result. Now the sensitivity parameter, we talk about sensitivity. I already explained, like it is the ratio of undisturbed shear strength to the remolded shear strength. So the this soil classified also on the basis of sensitivity, that how sensitive it is. There is a table is there in a geotechnical engineering which say that after that this soil is more sensitive for collapse. And when you talk about the quickly the associated with the marine environment, in marine environment offshore region, this type of condition get developed in a soil. I will explain those things in coming classes. Today, by just terms need to be understood by you. So, what is the importance of infrastructure development? When you talk about the infrastructure development, so over there we talked about the offshore environment. Here we implement. Now we come about the importance of infrastructure development. So the offshore development, in offshore also we want to develop the structures, and because the India is a growing economy, so we want to develop the each and every part of the country, not only the plain region. Over there at the different places. So we talk about earlier, we talk about geotechnical engineering. We could construct the slopes, we could stabilize the different slopes and dams. We could construct some of the construction on hilly terrain, and those aspects need to be explored. So it is very important that every so this value or calculation of the shear strength, understanding of the shear strength of soil will help us in this, in that regard. Now talk about the some of the challenges and opportunity for the engineers when we talk about a shear strength. So engineer solution for the soft clay in marine environment will be provided with the help of this test as well. And engineering software, what is engineering software? The starting point for the understanding and imagining the sensitivity of soil. Now I will conclude this section over here, and afterwards some of the aspects which we understood today and some of the homework for you will be I will state to you, so you can go ahead. And I am sure that there are very less attendance over here, but I have seen that several people came on YouTube and see my video. So if you are watching over here on YouTube, so please go across the some of the homework which I provide. That is not the compulsion for you, but it will be far better if you go with that. Then you will understood the entire aspects of the discussions, whatever takes place today or in last three sessions specifically, and see. So the behavior test is a bridge gap between the 2D and 3D soil testing. Specifically, it is mentioned that the plane stain and the triaxial test it is act as a bridge between them and a valuable tool for accessing the shear strength of the sensitive soil. And it is also important that at some places where we are not able to find the value of shear strength, we are not able to perform the test like the direct shear and the triaxial test over there. Also, the Bayesian shear test could be performed with the ease, and we get some of the result that will help us in stating that this will be the strength of the soil at this location. Okay, so moving ahead, the second point is over here is through a Bayesian test, the engineer gain insights into the cohesion mobilization pattern, both vertical and horizontal plane. The vertical horizontal planes are sorry discussed over there and enabling more informed discussion in the infrastructure development, especially challenging environments like offshore regions. So those aspects are taken into account. And now I have already told you that some of the correlations I have written, like this is the relation interrelating the settlement. So the consolidation settlement, immediate settlement, basically elastic settlement. So immediate settlement could be calculated with the help of this interrelation BQ into 1 minus mu square by E into IB, where IB is the influence factor and it depends on the dimension of the foundation. And one thing you must understood that we are going to some of the very good problems on the basis of this in subsequent classes. Over there, you will get the idea that how the application of load, how the dimension of foundation will ultimately help us. Moving ahead, I will state you some of the challenges which we came across our during our shear strength. So the some of the challenges are the soil variability. Specifically, it has been seen that soil get varied at different places. There are the different soil property are there. So the compaction energy get also different, and the when we go for different places, different environmental conditions, different soil types, different plains, different uh, in sections like in plain, in slopy region, in hilly region, or in the mountainous region. So the different soil property are there. So the different tests need to perform at different places to find the shear strength accurately at those locations. So some other factors like soil saturation level and the time under the stress, like some points are there over the stress are applied from a very long time. So that aspects also need to be understood and also impact the soil strength compacting analysis and the accuracy for instruments. Okay, we are performing the different tests like direct shear test, triaxial test, but the instruments we are using, the methods we are performing those tests, and what are the results we are getting from theirs are equally valuable for us because on the basis of those results only we are stating that this type of soil has this much strength. So those need to be understood and those need to be considered at a well extent for us doing before stating any strength. Some correlations are there. Now we talk about the sum of the current and future research scope of the strength analysis. I am not telling that here we are closing the topic, but for today, I have decided to close over here. So I have added some of the future research which we could perform in this field, like the advanced smart sensor advancement in sensor technology allow the more accurate and cautious monitoring of the soil conditions, providing new data for the analysis and improving the safety in the various applications. Machine learning, using the machine learning algorithm can help interpret and integrate the large quantities of data from the various sources to improve the accuracy of the soil strength analysis. Apart from that, the bio-inspired solution, when we talk about the bio-inspired solution, the researchers are working on creating a new ways to improve the soil stability by sorry, drawing inspiration from how material and structures in network work. So this is the future aspect. So you need not to worry up to that extent about this. This is the only things which I implement to you that will help you to understand the topic. So again, one question remains fixed from the first class only, that what is the shear strength. So the basic aspects of shear strength. So whenever I give this question, try to write this question with your own. If you are able to write those problems, then it will help you, it will give you deep understanding of the topic, like what is the shear strength. Give the practical implementation, that why the soil fail at certain sections only, why it doesn't fail from other points, irrespective of what we are implementing, that soil fail from this section only. So those aspects need to be understood by you. So, when we talk about the shear strength, there are the definition of shear strength is given in the different term. Try to write by your own, and afterwards also try to found the um, different terminology when we say about the shear strength, to define the different uh, in a different way, defining the same shear strength. So it will enhance your understanding and writing capability in that regard as well. And other thing is the direct shear test, which we discussed last class. I have again mentioned that to write it in detail. If some of you haven't gone through, also perform this test at your institute. That will enhance your understanding about direct shear test. Direct shear test is nothing but box test, which we discussed during the last class. I also give some of the insight during this class as well of this test. And apart from that, we have broadly discussed sorry, behavior test today. So you must go across the behavior test. You write the detailed procedure, which is also mentioned in this presentation as well. You perform this test, note down the result, find the value of the shear strength of some soils in a laboratory if it is possible. If it is not, please go across the some of the tutorials, some of the presentations over there across the different channels or YouTube. So to see the practical how we are going to perform in this field, in that field, so you will get the better idea. And other thing is the effect of cohesion and friction angle of shear strength. It has a wide discussion. From the last three class we have discussed in a different way that how cohesion and friction angle affect the strength of soil. One another point I haven't mentioned the question. That question is like how the cohesive and cohesionless soil behaves. Another question could also be made like what are the different triaxial tests, how the drainage condition affect those tests. So those questions you could answer, you could frame the question by yourself and then write the answer for that. So that will enhance your understanding of the topic up to a larger extent. And apart from that, we have also studied the elastic settlement, the relation like QB into 1 minus mu square into IB by EF. And the consolidation is also studied today, that how consolidation work, how much time it will take for the cohesive and cohesionless soil. So those things we have taken during the today class, and the some of the differences are mentioned over here. Apart from that, when you go to the NPTEL website of the site, over there the several reference book are also mentioned. So please go across those books and find the problems and try to solve. If you have any problem in solving any of the problem, you can ask me during this interaction. I will also come with some of the problem when those topics are discussed in the class, which on which I can frame the problems. So I will solve those problems as during my first two lecture also. I have solved the problem whatever could be made, the potential numerical problems which could be made on the topic. So I will solve again some of the more problems if those are there during the discussions, the topics which get solved out in this class coursework. So those problems I will discuss as well over here. But up to that, whatever I have discussed specifically in the first and second class, some problems are there. So please try to solve those problems again by your own hand, and also write the solution for the problems which I have implemented during the last three slides, and last by mentioning that question to guide your reading. So please try to write this in your own word, and this will help you. Basically, when there is no compulsion, everyone want to leave it, just do the assignment and go ahead, but not do like that. It will increase your understanding about the subjects, and when you go for the exam for the subject, This will help you more often apart from what you are doing right now, like solving the simple problems like MCQ. So those questions are will be solved, need to be solved, must be, but please go with some of the problems. Apart from this, the several references are there on the NPTEL site. Go with those books, solve the problems from those books. Whatever problem I have discussed, the similar problems are also there. The more aspects of problem may be there. If you have any doubts, you can come over this platform and ask me. I will try to answer and give you the solutions in your I will try to solve your query. So that's it all from my side for today. And thank you for all your presence over here. And I will again try to mention one point. Those who are going to watch in YouTube, please solve the problems, solve the questions which I have mentioned. Try to write these questions with your own. That will increase your concept, that will enhance your understanding of the topic. With that, I will end the today's sessions. Uh, I think so. The time will already go up, so we will end the session over here only. And with a fine note, wish you a very happy weekend. The coming is a Independence Day, so wish you a very happy Independence Day in advance. Uh, Enjoy weekend and celebrate the Independence Day. Remember our independent, our freedom fighters on the in this week. And with this, I will end the session for today. Wish you a very happy weekend and wish you a very happy Independence Day in advance. Thank you.